Now we will see when we have more than one predictors. So we can write the regression equation as y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 up to beta n xn plus epsilon. Here also we will follow all the 4 steps that we followed in simple linear regression. But there will be one additional step here, which is step 3, that is variable selection. So in this step we will evaluate and see if all the variables must be included or there are certain variables that contributes more than others, and accordingly we'll make the selection of variables. So let's see how we are going to do it. First we will estimate the coefficients exactly in the same way as we did in simple linear regression. Then in the next step we will check if there is a relationship between x and y. So we will test the null hypothesis as beta naught is equal to beta 1 is equal to beta 2 up to beta n equals to 0. And our alternate hypothesis will be if at least one of the coefficient is not equal to 0. Then we can say that there is a relationship between x and y. So here we will calculate f statistic instead of t statistic as per the given formula here. Just have a look at it, you don't have to remember it. So the entire process will remain the same. It is just that we are using f statistic here instead of t statistic. And then as usual we'll compare it with p-value to decide upon the hypothesis. Now one thing I would like to remind you that we are coming across so many formulas here and there are so many theoretical concepts as well. But as I said earlier, if you see a complicated formula, then just remember that you don't have to remember it. All this will be done by the software, but it is very important that you understand the theoretical concepts and do not ever get swayed away by the stupid claims that say we already have softwares for everything, we don't have to know the theory part. You don't have to mug up the theory, but you must the theoretical background, then only you'll be able to use the software successfully. So just pay attention to the theoretical concepts and get yourself acquainted with it. Now let's move on to the next topic. So as I said earlier, there is an additional step, that is variable selection. Now in MLR we have more than one variable. So it is important that we know that which variables are relevant and which are not. Accordingly, we will include only those variables that are relevant to our model. This process is called variable selection. Now there are multiple ways to select the right set of variables for the model. First among them would be business understanding and domain knowledge. For instance, while predicting sales, we know that marketing efforts should impact positively towards sales, and it is an important feature in your model. So business understanding, domain knowledge will always play an important role in data science. We have to use both our tools as well as experts' opinion. Another way is that we start with 0 variables and keep on adding and try all different combinations of variable. And then we have metrics like MelloCP, AIC, BIC, adjusted R-square or plot of residuals to select the best model. But the problem with this approach is that we will have to build models from 0 variables up to p variables, which is like 2 raised to the power p combinations, and that would be too many models. So this is not the best and efficient approach. So let's see what are the other techniques that we can use for variable selection. Now there are many techniques for reducing the variables. All of these techniques can be applied to a variety of algorithms. So we will see the first 3 techniques: forward selection, backward selection, and mixed selections here in this video of linear regression. Then ridge regression and lasso regression are also called as regularization techniques that we will see when we will do logistic regression. Then we have dimension reduction techniques like principal component analysis, factor analysis, etc. We will see principal component analysis in the next module, that is advanced modeling. Then there are few other optimization techniques such as genetic algorithm, ant colony optimization, and various other techniques are there. Now we will not be looking into all of these techniques. We will restrict ourselves to 6 methods that are more than enough for us to learn. So let's start with the first method, that is forward selection. So in forward selection, as you can see on the right hand side, we start with the null model that has no variables. Then we create models with single variable and select the model with lowest RSS. Now search through the remaining variables and select which variable to be added based on RSS. And then we'll create another model and add another variable based on RSS, and so on. This process will continue until some stopping criteria is obtained. Now the stopping criteria could be user defined, such as when all variables selected has a p-value less than a certain value, or it could be something else. Now there is a drawback of this method, that is it may include variables in the early steps that later becomes redundant. That is why it is also called a greedy approach. Then the next method is backward selection. Here we start by including all the variables as shown here in the image on the right hand side. Then we start removing variables with the largest p-value, that means which are least significant. And then we continue this process until some stopping criteria is obtained. Now the drawback of this method is that it cannot be used when p is greater than n, means the number of variables are more than the number of observations. Then the third method is mixed selection. Now as the name suggests, it is a combination of backward and forward selection method. So here we start with no variable in the model as shown here in the image, and then add new variables to it. And then at any point, if p-value of any variable crosses the threshold which is defined by the user, then the variable is dropped. So we continue these steps until all the variables have a p-value below a certain value. Now mixed selection addresses the drawbacks of both of our earlier methods. Hence it could be considered a better approach. Now after performing variable selection, our next step is to check the accuracy of the model. So we use the same metrics here as we did in simple linear regression, that is RSE and R square. Also as we discussed earlier, R square will always increase when more variables are added to the model, even if those variables are only weakly associated with the response. So to address this problem, we can use adjusted R square. This is what we have already discussed. After this, once all the previous steps are performed and our model is ready, we can use it for making the prediction. Now it's very easy to predict the response. We just have to plug in the coefficients and the predictors in the regression equation, and this will give us the predicted response variable. So that is how we do multiple linear regression.